Have you ever stopped to think about how an email you send from your laptop finds its way to a server halfway across the world in, like, a few seconds? It's not magic. Not at all. It's the internet's incredible invisible navigation system, the network layer. So let's pull back the curtain and really figure out how our data travels across these glowing digital highways.
And you know what? That is not an exaggeration. This one layer, Layer 3, if you're keeping score, is truly the heart that pumps our data all over the globe. It's the master coordinator, the one responsible for guiding every single message, every video stream, every bit of data to exactly where it needs to go, no matter how far.
All right, the best way to think about the network layer is as the master navigator for your data's journey. It's kind of like a global GPS, a traffic controller, and the entire postal service all rolled into one powerful system. So what's on its to-do list? A whole lot, actually. It doesn't just fling data out into the void and hope for the best. No, it intelligently routes these little bundles of data, called packets, between different networks. It's always choosing the most efficient path, assigning a unique address to every single device, and physically pushing that data along its journey. It basically writes and enforces the rules of the road for the entire internet. Okay, so before any trip can even start, you need two basic things, right? A starting point and a destination. Well, on the internet, that means every single device, from a massive web server to the phone right there in your hand, needs its own unique address. And that address is the famous IP address. It's absolutely fundamental. Without a unique IP address, your device would be a ghost, completely invisible and isolated on this massive network. You wouldn't be able to send or receive a thing. We've actually had two main generations of these addresses. IPv4 was the original, but with only about 4 billion addresses available, we just ran out. That's what led to IPv6. Its 128-bit structure gives us a number of addresses that is just mind-boggling. We're talking more addresses than there are stars in the known universe. So yeah, the internet has plenty of room to grow. So we've got the addresses. Cool. But how does the data itself actually travel? Well, it gets bundled up into something called a packet. The easiest way to think of it is like a digital envelope. The header on the front has all the critical delivery info, the source and destination IP addresses, while the payload inside is your actual data. All right, so our data is packaged up, it's got an address, and it's ready to hit the road. This brings us to the real magic of the network layer, how it navigates the unbelievably complex roadways of the internet. And I mean, really think about that. Between you and a server in another country, there could be billions of potential paths. How on earth does your packet not just get hopelessly lost?
The answer is this amazing device, the router. These are the intelligent traffic directors of the internet. A router's entire job is to sit at a digital crossroads, look at a packet that just came in, and make a split-second decision about where to send it next to get it one step closer to its final stop. And this whole process is incredibly efficient. A packet zips in, the router doesn't care about the data inside, it just glances at the destination IP address on the header. It checks its internal map, called a routing table, to find the best path, and bam! It forwards the packet to the next router on that path. We call that the next hop, and this all happens in milliseconds.
But here's the really cool part. These maps aren't static. They're not printed out and then outdated a minute later. Nope, they are alive, constantly being updated. Routers are always talking to each other, using special protocols like OSPF and BGP, sharing real-time info about traffic jams, new shortcuts, or maybe closed roads. It's a living map. Okay, our packet has crossed oceans and continents. It's been guided by all these smart routers, and it's finally arrived at the right local network. Let's say your home Wi-Fi. But its journey isn't quite over yet. It now needs to find the exact device. This is the final handoff. And this is where we see this beautiful collaboration between different layers. The network layer's IP address gets the letter to the right building, the right zip code, but then it's layer 2, the data link layer, that uses a physical MAC address to deliver that letter to the specific mailbox on the street. It's the difference between global and local delivery. So, how does this handoff actually happen? Well, the local router basically just yells out a question to every single device on the network, uses a little protocol called ARP, and it just asks, hey, I've got a packet here for IP address 192.168.1.100. Who has it? And out of all the devices listening, the correct one raises its hand and says, yup, that's me. Here is my permanent, unchangeable hardware address, my MAC address. And just like that, the router now knows exactly which physical device gets the packet. The journey is complete.
So I know this has been a lot of technical talk. Packets, routers, addresses. It can seem pretty abstract. But the thing is, this incredibly complex dance is happening constantly, and it's the foundation of pretty much everything you do online.
I mean, every single one of these things, every web page you load, every video you stream, every message you send, every game you play, is really a massive storm of packets being expertly navigated across the internet by the network layer. It's the silent, absolutely essential engine of our digital lives.
But, what happens when things go wrong? Well, the network layer has its own built-in messenger service called ICMP. It's the thing that sends back error messages like destination unreachable when a server is down. It's also the protocol behind the ping command that lets us check if a device is even online. It's the network's own little feedback system.
So just let this sink in. These routers, these digital navigators, they make trillions of correct decisions every single day with unbelievable speed and accuracy. But in a system this complex, this massive, mistakes can and do happen. It really makes you wonder, what does it look like when a major part of this global navigation system fails? How fragile is this digital world we've built?